NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
Since 1917, NASA's Langley Research Center, Hampton, Virginia, has been serving this country's needs both in aeronautics and astronautics. Recalling some of the early history, senior historian and curator for the Smithsonian's National Air and Space Museum, Mr. Paul Garber.
Welcome to the Smithsonian Institution National Air and Space Museum. The third head of this institution was Samuel Pierpont Langley, for whom the laboratory at Hampton, Virginia was named. And his successor, Charles Doolittle Walcott, as early as 1912 realized that we should have here in America a laboratory where scientific investigations could be made of the basic facts of aeronautics so that our aircraft could be developed further. This is probably the most famous award in the history of flight. It was donated in 1912 by Robert J. Collier, who was then head of the Aero Club of America. It is awarded annually for the greatest accomplishment in aeronautics or astronautics, the value of which has been proven by a previous year of practical use. 8 times those awards have been either directly to NACA or NASA, that is the National Advisory Committee for Aeronautics, or the National Aeronautics and Space Administration, either directly or in connection with some development with which they were associated. The award for 1929 was the first one to NACA, and that was for the engine cowling on the front of an airplane or on the engines of an airplane. This cowling was a cylindrical sleeve that fit over the cylinders of the engine. Now, on the Spirit of St. Louis, those cylinders protrude, and by protruding cause so much friction of the air that they are a serious drag to the speed of the aircraft. But by development of the NACA cowling, that engine could be so enshrouded, so smoothed, so streamlined, while at the same time the engine itself was better cooled, that the performance of aircraft was increased greatly. In fact, the application of that cowling to such aircraft as the Lockheed Air Express and to the Winnie Mae increased the speed appreciably.
It was during the years following World War I that Captain Charles A. Lindbergh made the first solo flight across the Atlantic, drawing worldwide attention to the potential of the airplane. Dr. Robert H. Goddard successfully developed and fired liquid-fueled rocket motors, events which would influence later history. These were the post-war years. At Langley, wind tunnels were being constructed, wind tunnels able to test models in free flight, making accurate measurements and corrections before a plane was built, pointing the way to improved airplane design concepts. To help determine the spin characteristics of aircraft, a spin tunnel was so designed that models could be spun simulating full-scale free flight. This same facility was used also to test out models of all of the manned spacecraft, Mercury, Gemini, and Apollo. During the second decade at Langley, 1927 to 1937, the dirigible, plagued by a series of tragic accidents, and the biplanes faded from the scene. In their place, the all-metal single-wing craft, predecessors of our commercial airlines, planes with 2 rather than 3 air-cooled engines and retractable landing gear. The NACA was asked to determine the conditions which caused ice formation on aircraft and develop means of preventing it. These studies grew into a major effort that did in fact find a solution with the 1946 awarding of the Collier Trophy for the pioneering research. To serve the needs of the seaplane and amphibious airplane designers, the first of Langley's hydrodynamic test tanks were made ready for operation. towing a model hull through the water up to the point of a simulated takeoff speed, engineers could suggest improvements in the basic design. In later years, Mercury, Gemini, and Apollo water landing techniques would be checked out using the same tank. World War II dominated Langley's third decade. The urgency of the war dictated the programs of this period. Programs aimed many times at curing the immediate ills of already flying combat aircraft. Typical of these were the ditching studies. Here, a highly instrumented B-24 was crash-landed in the James River. Research aimed at giving over-the-water combat crews a better chance of survival should they be forced down. Other work during the wartime period included studies of airplane stalling characteristics, aircraft loads in maneuvering flight, and problems associated with diving and braking. Near the end of the war, Langley scientists were working on the idea of wing sweepback, an idea for attaining higher flight speeds. One method of experimentation was with rocket-propelled models. These early studies can be seen in present flying airplanes. High speed presented some problems of ejecting from an airplane. This test pilot was subjected to wind tunnel blasts at speeds up to 400 miles per hour to check human tolerance. October 1947, Captain Charles E. Yeager, piloting the Bell X-1, flew through the speed of sound for the first time and pioneered the way to supersonic flight. Speeds made possible by the long research effort that had begun early in the war at Langley. The next decade, 1948 to 1957, research continued on the X series of aircraft. These included the X-3, X-5, and the most significant airplane design, the X-15 Hypersonic research aircraft, shown here being proved out in a Langley wind tunnel. Today, the X-15 travels at speeds in excess of 4,000 miles per hour and is returning information about high-speed, high-altitude flight as it maneuvers close to the fringes of space. Research and flight tests of helicopters continued to take place to help determine future designs. A landing loads track began operation during this period. With it, aircraft landing gear could be subjected to the same type of load stress encountered during landing. Later tests identified the problem of aircraft and automobile hydroplaning as a result of water-drenched pavements, a condition that can cause loss of control. Speaking about his years in aviation, General James H. Doolittle, former chairman of the National Advisory Committee for Aeronautics.
This is my 50th year in aviation. I started in 1917. In those days, the airplane was very simple. There was a stick and wire contraption covered with cloth, and if somebody had drawn a picture of a modern-day airplane, we would have thought him slightly mad. Perhaps the best way to explain what's happened in aviation is to say that in those days, there was a fixed landing gear, simple engine, simple airframe. Then came flaps, slots, retractable landing gears, jet engines, air conditioning, pressurization, and all of the multiple, manifold communicational and navigational equipment, all the military equipment that's gone in, and the airplane from a very simple thing has become very complex. The most modern airplanes today cost something over $5 million, or 1,000 times more than they cost in 1917. This gives some indication of the increased complexity of aviation and, of course, the improved performance and utility of aircraft today. But part of that, of course, is due to a reduction in the purchasing power of the dollar, but most of it is due to the things that have been put in the aircraft. Now, if we look at this airplane over here, we see a subsonic airplane flying at around 600 miles an hour, crossing the continent in about 5 hours. I see in the future the supersonic airplane that will cross the continent in something over an hour. And prior to that, there's the very large airplane, the Boeing 747, the Lockheed C-5A, which will greatly reduce the cost of air travel and tremendously increase the amount of air travel. It will have a profound effect on air cargo and the amount of air cargo that's carried. There will also be the VTOL and STOL aircraft that will make it more convenient to fly and will save time over short distances. All of these things are coming.
To study the heating problems generated by re-entry flight into the Earth's atmosphere, arc jet facilities were put into use at Langley. With the orbiting of the Russian Sputnik, getting men into space and returning them safely through the searing heat of re-entry became a high priority problem. Now, in the decade of the 60s, the Langley Research Center is charged with a dual responsibility: continue aeronautical research and contribute to the science of spaceflight. A space task group originally formed at Langley went on to become the Manned Spacecraft Center. By the end of the Mercury program, there was no doubt that man could live and work in space. At the White House, President Kennedy awarded the Collier Trophy to the first 7 astronauts.
And I'm particularly glad that the decision has been made to award the trophy this year to them. I think it honors an extraordinary page in American history as well as in the history of flight. And I hope that this award, which in a sense closes out this particular phase of the space program, will be a stimulus to them and to other astronauts who will carry our flag to the moon and perhaps even someday beyond. So it's a great pleasure I present to them this celebrated award.
Here are some of Langley's other projects. Echo, an automatically inflating satellite, grew out of a Langley concept and was developed there. Rendezvous and docking, critical to the Apollo moon program, was studied and determined feasible. Commercial supersonic transport. The initial configuration was developed to meet the unique flight requirements. Lifting bodies. This, the so-called HL-10, craft which may someday shuttle men and equipment through space, then land like a conventional plane at an airport. VTOL, vertical takeoff or landing aircraft, forerunners of intercity transports which fly forward at high speed and then set down like a helicopter. The concept for this tilt-wing craft evolved into the first operational VTOL transport. Lunar Orbiter, a series of moon mapping craft surveying safe landing sites for American astronauts, conceived and managed by Langley scientists. Airport landing studies, and the list could go on. Langley Research Center. In 50 short years, it has risen from a few buildings and facilities testing out biplanes to join NASA's national effort in both aeronautics and space. But it's really 50 years of people. People make the machines and design the test facilities and plan the missions.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.